Hello, my name is Professor White. Today we will talk about estimates and sample size, primarily how to calculate confidence intervals for proportions and means. So let's get to it. The first thing I will do is to calculate the confidence interval for a population proportion. If we look at the formulas, what we have is the population proportion in the middle is supposed to be between p hat plus e and p hat minus e, where e is the margin of error, and it has a pretty lengthy formula, which is complex. It has a square root and p hat and q hat. P is the probability of success, q is the probability of failure. Z alpha over 2 can be obtained from the tables, and I will not go into it. You can read your book to get those things from the table. And then once you have the Z alpha over 2, given a confidence interval, you can just plug in the formula to get the margin of error. Once you have the margin of error, what you need to do is add this to your actual proportion and subtract this from your actual proportion to get an estimate for the confidence interval. So let's look at an example. I have a situation where Mendel conducted his famous genetics experiment. One sample of offspring consisted of 428 green peas and 152 yellow peas. So we are talking about two types. If the question is, find a 95% confidence interval estimated of the percentage of yellow peas. So we are looking for the confidence interval for the yellow peas. So the first thing I need to do is I can get my Z alpha over 2. You can do that from tables, or you can do it from your calculator. If you have alpha over 2, if you remember how alpha over 2 is calculated, you're supposed to have this area and this area adding up to alpha. So you're going to have alpha over 2 from here and alpha over 2 from here. So we're talking about 95% confidence interval. That means this is going to be, the white area is going to be 0.95. All right? Now, if we are talking about inverse norm, what we're looking for, we are trying to get this alpha area is 5%. And that means this is going to go, if you have 5%, 2.5% from the right, 2.5% from the left, and that will give you 0.975, and you can calculate the Z alpha over 2 with the inverse norm. That happens to be 1.96. You can also get this from the distribution tables or just from your calculator. Now, let's look at the error. You have Z alpha over 2 and the square roots. So I'll plug in 1.96. P hat is going to be 152 yellow peas over 580, which is the addition of 152 and 428. This is your P, and then this is your Q, which is 428 green peas divided by the total number of peas, 580. And in the denominator, you simply have the total number of peas. That when you plug this in your calculator, you'll get 0.03579. So you may choose to do that in using the formula. And then what you need to do, this is your error estimate. What you need to do is just subtract this from your 0.262, which happens to be the proportion of the yellow peas, and you subtract the error estimate, and then you add the error estimate, and you get an interval 0.226 to 0.298 for the P. Now, an alternative method is to get to your calculator and then use the stat test button. So let's go to the calculator. When you go to stat, you have a couple of menu items, edit, calculate, and test. You have to go to the test. One way to do that is go to the right Now, I'm looking for proportion intervals. So if I go down, none of these tests are applicable. But if you look at option A, it says 1 prop Z interval. That is the one that you want. So what you need to do, you just select this by pushing enter. And then it will say, what is X? The X is the number of hits. So I have 152 yellow peas, 152. And you go down, and the total number of peas is 580. And then you have to put down the confidence interval. The one that I'm looking for is 0.95, so it's already in there. All you have to do is just go calculate and enter, and it will give you your estimate in the interval notation, which is 0.22628, and the upper limit is 0.29786. And it will also give you the p hat, which is the proportion of the yellow peas, and then n is the total number of peas in there. That is the end of calculating confidence interval for the proportion. Now, if we want to get a confidence interval for a population mean, where you know the standard deviation, you can also do that by hand. So your population mean is going to be your sample mean plus the margin of error, your sample mean minus the margin of error. And the margin of error is simply given as Z alpha over 2 sigma over square root of n, where n is your sample size and x hat is your sample mean. Let's look at an example where I have 80 students and they are found to have a mean of 4.8 years to obtain their bachelor's degrees. Assuming a standard deviation of 2.2 years, construct a 95% confidence interval estimate for the population mean. Again, as before, I can go and calculate 1.96 from the inverse norm with your graphing calculator. Then you can just plug that number in the margin of error formula. So you're going to have 1.96 times the standard deviation of 2.2 divided by your sample size, which is 80 students, square root of 80. When you plug that in your calculator, you will be getting 0.482. So what you need to do is you need to go and you need to subtract this from your sample mean of 4.8 years, 4.8 minus 0.482, 4.8 plus 0.482. You'll be going from 4.3 to 5.3. So again, it took us a little while to get that calculated. If you want to do this in your calculator, this is what you do. You have to go back to your stat test menu, and this time you are going to go get your Z interval. So let's do that on the calculator. I will go to the stat menu, and again I have three options. I will go straight to tests. Since I'm looking for mu, I will do the Z interval test, which is the number 7. When I pick enter, as you see, you have two options again, the data option and the stats option. Now the data option is you can actually, if you don't have the mu and the standard deviation calculated, you can actually use the data option to enter your data in L1. I will just show you really quick. If you enter that, you will have to put where you put the list in there. Now in this case, I don't have the data, but I do have the statistics. So I'm going to go and change that to stats. Now this time this is black, and it's going to give me a couple of things. Now the first thing it's asking, what is your standard deviation? I'm assuming the standard deviation is known. That's why we are using the Z interval, 2.2. And then your mean is known, and that is simply 4.8. And you have n. How many students are we talking about? 80, and the confidence interval of 0.95. When you go down and push calculate, you'll see that you'll get your answer in interval notation, which is identical to what we did, 4.3 to 5.3. And it will give you the mean again, 4.8, and n of 80. This is the end of calculating the confidence interval for the mean, assuming that you know the standard deviation. But when you do not know the standard deviation, what will happen? How are you going to estimate that? So let's go to the next case where I have a situation where the confidence interval, I'm looking for a confidence interval for a population mean, but this time I do not know the standard deviation. Now, when that happens, what you need to do, you have the same formula for the interval, the standard mean plus the marginal error, standard mean minus the marginal error, the sample mean, I mean. And the marginal error is going to be given not with z alpha over 2 this time when you don't know sigma. It's t alpha over 2. You'll be using the t distribution instead of z distribution. So what you can do, there are a lot of tables printed to be able to get the t alpha over 2. You cannot get it from inverse norm anymore. You need to get it from the degree of freedom of 189, which is 1 less than 190, and then for the confidence interval for the mean. And most statistics books do have those tables printed in them. Now we are looking at the t distribution. So let's look at the example. In a study for cocaine use on infants, data were obtained from 190 infants with a birth weight of 2,700 grams with a standard deviation of 645 grams. Calculate the 95% confidence interval for the mean. So we're talking about baby weights. So if you look at the formula, I obtained the t value from the table, and that's 1.972. And this time, since I do not know my population standard deviation, I will use the sample standard deviation. Sample standard deviation on top, square root of my sample size at the bottom. When you plug everything in, you will get 92.276226. Keep as many digits as you can until the very end. Then you do your rounding at the very end. Now, 2,700 is my mean. Subtract the margin of error, add the margin of error. That will give you 2608 to 2792. So let's go to the calculator steps. Here are your steps. So I have to go again the stat test menu, and then this time I have to pick the t interval instead of z interval since I don't know the population standard deviation. So let's go to the calculator. I'll clear the calculator and I'll pick stat, test, then I will go down to t interval instead of z interval. When you pick that up, again, I have the option of picking the data or statistics. Since I do not have the data, I will go with the statistics. The first thing it's going to ask me, what is your sample mean? In this case, my sample mean is simply 2,700. And my sample standard deviation is simply 645. And how many infants are we talking about? 190. And the confidence interval of 95%, which is given. Then all I have to do is push calculate. It will take a little longer because the routine is a little longer, and then you will get your estimate, 2608 to 2792, which is exactly what I obtained last time. This actually concludes the estimating part of confidence intervals, for proportions, for sample mean, knowing the population standard deviation, and for sample mean, not knowing the standard deviation. So in case of the proportion, you need to use the 1-prop z-test from your calculator. In case of the mean estimate, you have to use the z-interval. And in case of the lack of standard deviation known for the population, you have to use the t-interval test to do these calculations.